Hello friends, this is Priyanka. Today we are going to solve a problem on performance of different power plants. In this video, demand curves for consumer A and consumer B is given, and we have to calculate amount of fuel required to supply power to consumer A and B separately. Then we will find out the load factor for consumer A and B, and we will find out the load factor when power is supplied consumer A and B simultaneously. We will find out the savings in fuel per day when the power supplied to consumer A and B simultaneously. Now first I will read what is the given question. The demand curves of the consumers A and B are shown in diagram in megawatt on the basis of 24 hours. If it is assumed that the demand of each is supplied by same plant on the average load basis, then find out the amount of fuel required to supply the power to both consumers in turns per day. Find out the load factor of each consumer and load factor when both are supplied the power simultaneously. If the demanded power by both consumers is supplied simultaneously, then find out the savings in fuel per day assuming that the supply is given on the average load basis. The capacity of power plant is equal to 50 megawatt. Calorific value of fuel used is 32 megajoule per kilogram. The plant follows the following law for the thermal efficiency, that is neta thermal is equal to 0.35 percentage load on the plant raised to 0.62. So this was the given question. We will first draw the load curve when the power is supplied to consumer A and B simultaneously. Now if we observe the given demand curve or load curve for this A and B separately, then on this vertical line load in megawatt is given, and on this horizontal line time in hours is given. So here total time duration is 24 hours. Now if we observe here the parts are made, that is for this total 24 hours are getting splitted into number of hours, that is 4. That is 0, 4, 8, 12, 16, 20, 24. So these are same for both these consumers. So in the same way we will plot here one horizontal line and we will make the partition, that is from 0, 4, 8, 12, 16 and so on. Now here the load in megawatt is given and this partition is for 10 megawatt, that is 10, 20, 30 and so on up to 50. So in the same way we will make here the vertical line. Now if we observe the duration in between this 0 to 4 for this consumer A, load is 10 megawatt, and here also the load is 10 megawatt. So when the combination is made or power is supplied to both the consumers, then here in between 0 to 4 this 10 plus 10, that is 20 megawatt we have to supply the load. So I will make here the line for 20 megawatt. Then in the same way for 4 to 8 here is 10 and here is 20. So 20 plus 10, that is 30. So I will make here one line, that is for 30. Then for 8 to 12 here is 30 and here is 20. So 30 plus 20, that is 50. So for 8 to 12 we have to make here one line for 50. Then 12 to 16. So 12 to 16 here is 15. So if we observe here is middle line in between 10 and 20. So here is 15 and here 20. So 20 plus 15, that is 35. So we have to make here for 12 to 16, that is 35. Then for 16 to 20 again here is 15 and here 30. So 30 plus 15, that is 45. So we have to make here one line for 45. Then 20 to 24. Here is 15 and here is 30. So 30 plus 15, that is again 45. So we will make here one line. Now we will join all these lines. So this is the combined load curve that is getting completed. Now we will show what is the average load for each, that is for consumer A, consumer B, and here for consumer A plus B. So we will show here. Now for that we will first find out what is the energy generated by this consumer A when the power is supplied to the consumer A. So what is this energy generated? That is nothing but area under this curve. So here this is the load curve and we have to find out the area under the curve. So how to find out the area under the curve? So this total area is the addition of different sections. So I will show this section with the help of dash line. So here is the section 1 in the form of rectangle, here is the second rectangle, and here is the third rectangle. So now we will add this area. So what is the area for this first rectangle? That is this base length multiplied by height. So base length is for 8 hours multiplied by height is for 10 megawatt plus. Now for this second 8 to 12. So 8 to 12, that is 4 hours multiplied by height, that is 30. Then in the same way 12 to 24. So plus 12 to 24, that is 12 hours and height is for 15. So when we calculate this we will get the answer 380 and unit is megawatt hour. Or we will say megawatt hour, that is H, MWH. So this is the unit. Now in the same way we will calculate the energy generated when the power is supplied to consumer B. So in the same way here is also there are different sections, that is area under the curve. So what is the energy supplied to this load curve? That is this area under this curve. So here are total 3 sections. So for this first section 4 hours multiplied by 10 plus, now here 4 to 16, that is total number of hours are 12 multiplied by 20 plus 16 to 24, that is 8 multiplied by vertical line, that is 30. So when we calculate this we will get here 520 megawatt hour. Now in the same way for this combination of A and B. So again I will make the area under the load curve. So here there are different sections. So for the first section here number of hours 4 multiplied by 20 plus here 4 multiplied by, so here duration is 4 hours multiplied by 30 plus here 4 multiplied by 15 plus here 4 multiplied by 35 plus here 4, sorry here 8, total section is 8 hours multiplied by 45. Now when we calculate this we will get the answer, that is 900 megawatt hour. So these are the 3 energy generated. Now we will find out what is the average load. So average load for this when power is supplied to A, average load when power is supplied to B, and average load when power is supplied to A plus B. Now what is this average load? That is nothing but the total energy generated divided by time period. So time period in hours that we have to take, and here for each time period is for 24 hours. So simply here 380 divided by 24, 520 divided by 24, and here 900 divided by 24. Now we will calculate this and we will show the average load. So 380, that is 15.8. So what is the unit here? So this hour is getting cancelled because in denominator there is hour. So 15.8 megawatt. Now in the same way 520 divided by 24, that is 21.66. So 21.6 megawatt, and 900 divided by 24. So it's 37.5 megawatt. So now we will show show this to the load curve. So average load, I will show this. First is 15.8. So it is above this 15. So I will show here in the form of dash and dot line. So here is 15.8. Then 21.6. So for this 21.6, and 37.5. So here is 35. So above that we will show 37.5. So this average load is getting calculated. Now we will calculate the load factor. So load factor means what? That is average load by peak load. So this peak load we will observe from these diagrams and we will select. So load factor, average load is 15.8 divided by peak load. So here peak load is 30. Then for B, average load 21.6 and peak load, so peak load here is 30. And then here for A plus B, average load is 37.5 and peak load is 50. Now we will calculate with the help of calculator. .52. Now here average load and peak load, so both are having unit in megawatt, so it is getting cancelled. So no unit is there. 21.6 divided by 30, 0.72. And here 37.5 divided by 50, that is 0.75. Now we will calculate amount of fuel required to supply power to consumer A in tons per day. So for that we will apply the given formula, that is thermal efficiency. So it is given that 0.35 multiplied by percentage load on the plant raised to 0.62. But we have formula, that is neta thermal is equal to 3600 divided by m dot f, that is the mass flow rate of the fuel, that is fuel supplied per unit of time multiplied by calorific value. So here is formula. So we will apply here both the formulas. Now according to first formula, 0.35 multiplied by percentage load on the plant. So how to calculate the percentage load on the plant? Now if we observe, this is the average load divided by capacity of the plant. So capacity of the plant is given, that is 50 megawatt. So 15.8 divided by 50 raised to 0.62. So if we calculate here, we will get 0.17 and which is equal to 17%. Now we will apply the second formula. So this second formula is thermal efficiency is equal to 3600 divided by this mass of fuel supplied per unit of time multiplied by calorific value. Now if we observe here, this thermal efficiency for this A is known, that is 0.17. So we will put here this value. Then 3600 is the number and here calorific value is also given in the question. So this 32,000 we have to put here calorific value, and unit, when we take this formula, then unit is kilogram per kilowatt hour. Now this value is known, so only one unknown value, that is the mass of fuel supplied per unit time. So this mass of fuel supplied per unit time we can calculate, and it is 0.66 kilogram per kilowatt hour. Now we will calculate what is the total mass of fuel supplied to consumer A. So if we observe what is the formula, that is this is the mass of fuel supplied per unit time multiplied by energy generated. So here energy generated for this consumer A is nothing but area under this load curve, and we have already calculated this area under the load curve, that is 380 megawatt hour. Now we will observe here the units. So we have to multiply with this energy generated with mass flow rate of fuel. So here unit is kilogram per kilowatt hour, and here unit is megawatt hour as per our calculation. So we have to convert this megawatt hour into kilowatt hour. So we will take here 380 multiplied by 10 raised to 3. So it will become kilowatt hour. So here 0.66 into 380 multiplied by 10 raised to 3. So this kilowatt hour is getting cancelled, and here this is the formula for MFA total. So total period for 24 hours. So we can say that it is kilogram for 24 hours. So when we calculate this, then we will get the answer in kilogram for 24 hours. But we have to calculate it for the tons per day. So how to calculate this tons per day? So we have to divide it by 10 raised to 3. So when we divide it by 10 raised to 3 or 1000, then it will become only 380 multiplied by 0.66. So it is 250.8. So here answer is 250.8 tons per day. Now in the same way we will calculate what is the amount of fuel supplied to the consumer B. So here we will apply the given formula 0.35 multiplied by percentage load. So percentage load is nothing but here this is the average load multiplied by the divided by the capacity of the plant. So capacity is 50 megawatt. So 21.7 divided by 50 raised to 0.62. So it is 0.208 which is equal to 20.8. Now we will apply the other formula. So this is the thermal efficiency, that is 0.208. We will write here, which is equal to 3600 divided by m dot f, that is the amount of fuel supplied per unit time, multiplied by CV, that is calorific value. So here only one unknown term, that is m dot f. So here m dot fb, because we are going to calculate for this b. So m dot fb is equal to 0.54 kilogram per kilowatt hour. Now from this we can calculate what is the total amount of mass of fuel supplied. For that we have to calculate, or we have to multiply this with energy generated. So energy generated is nothing but area under this load curve. So for this area under the load curve we have calculated, and it is in megawatt hour. So we have to convert it into kilowatt hour, because here the unit is kilowatt hour. So when we multiply these two terms, that is the energy generated multiplied by this mass of fuel supplied per unit time, then here 0.54 multiplied by 520 into 10 raised to 3. So here kilowatt hour is getting cancelled, and it is in kilogram per day. But in question it is mentioned that we have to take the unit as a tons per day. So we will divide here with 1000, so which is equal to 280.8 tons per day. Now we will calculate the amount of fuel required when the power supplied to both consumers A and B simultaneously. So we will apply the first given formula for the thermal efficiency. For here we will write A plus B, that is 0.35 multiplied by percentage load. So percentage load is nothing but here the average load divided by capacity. So average load 37.5 divided by 50 raised to 0.62. So here 0.293 which is equal to 29.3. But we have here formula thermal efficiency is equal to 3600 divided by mass rate of fuel supplied into calorific value. So here also neta thermal for this A plus B, which is equal to m dot f A plus B we have to take. So here only one unknown term, that is m dot f A plus B. So if we calculate this, because we have to take this neta thermal 0.293. So when we put here 0.293, then we will get here 0.384 kilogram per kilowatt hour. So this is the amount of fuel supplied per unit of time. Now how to find out the total amount of fuel supplied? So for that we have to again multiply here the energy generated for this load curve, that is nothing but area under this load curve. So how to calculate it? So we have already calculated and it is in megawatt hour. So we have to take into, or we have to convert it into kilowatt hour, that is 900 into 10 raised to 3. So this kilowatt hour is getting cancelled, and we will get, when we multiply here with 0.384 multiplied by 900 into 10 raised to 3, that is kilogram per day. And but here in the question it is tons per day, so we will divide here with 1000, so we will get the answer 345.6 tons per day. Now we will calculate what is the fuel saved when power is supplied to A and B simultaneously. So for that we have to first add what is the total amount of fuel that is supplied to this A plus total fuel that is supplied to this B minus this fuel supplied to A plus B. So here we have to take the total amount, and unit we have to take the same, that is the tons per day. So what is this MFA total? That is for this 250.8 plus for this B it is 280.8, and we have to take the minus sign because we have to consider, or we have to find out what is the fuel saved. So for this the value is 345.6. So when we add these two and subtract this value for the amount of mass of fuel, then we will get 186, and we will take the same unit, that is the tons per day. So this is the fuel saved when power is supplied A and B simultaneously.